So in the last session, we talked about Streamlit, right? So with this Streamlit, I think our foundation part is over. So what we have done so far, let's quickly recap. So in the initial session, the very first session, we talked about what is AI, what is machine learning. In fact, we trained a couple of models, right? We trained a neural network, we trained one logistic regression, like that. And in the next session, we talked about basically what are the different applications, right? LLM based applications. We saw different applications of LLM, how we can use the power of large language models to build the applications. And then we saw what is LangChain, which is a framework basically, which help us to build the applications quickly. And then we saw advanced concepts of the LangChain, right? And after that, we studied about the Streamlit, which is a Python library which help us to quickly develop our user interface. Okay, so usually Streamlit is being used to develop POC kind of applications, not the production grade application, but still there are uh, cases where people also use it for the production purpose as well. All right, so with this foundation, now we know how the large language models work, how they generate the tokens, what is streaming. It's a text in, text out machine, right? So we know all the concepts, how we can inference our models. If you want to inference Grok models, which are deployed on the Grok platform, and if you need to invoke the OpenAI models, there are two ways. One is the OpenAI models, which are hosted in the OpenAI infrastructure. And second is if the OpenAI models are deployed in the Azure environment, that also I have shared that video, right? So anyone has any questions so far uh, on these topics before we start one of the most important topic, which is RAG basically. Okay, so let's start the RAG. So we have seen LLM basically is a text input, text output machine. And let's say I have a large language model. I'm using a large language model which had the cutoff date on 2023, right? And whatever information that company who trained that LLM model they collected was only up to 2023. So we call it as a knowledge cutoff date. So if you go and see any model which is there in the market, there is always one cutoff date, knowledge cutoff date is mentioned in its card basically. So what happens is whenever the knowledge or the training stops and whatever events which has occurred after the cutoff date, basically the LLM is not having any knowledge about it, right? If we talk about any recent event, the prime minister's visit to any country, or maybe vice president resigning from his post, like any cricket series. So that LLM is not having those information because it has not been trained on that data, right? All those things occurred after its training was over. So that way, it lacked that information. Also, if we talk about domain specific knowledge, all these models are basically trained on, some generic information which is available on the internet, right? So, for example, GPT models are trained with, they have general sense of all the domains basically. Can you guys mute yourself? I think someone is unmuted. Thanks. Right. So these large language models basically lack domain specific information. If you ask anything particular, let's say if you ask some legal question, right, which a lawyer knows basically, which is very much specific to a particular domain, right? Or if you ask any, medical related question, right? So then that LLM may not be able to answer because it has been trained only on the general information, not the domain specific. Second, we have already discussed, it also lacks the real-time information because it is having some cutoff date. So it won't be able to answer on the questions which are or on the events which have occurred recently. Correct. Third main thing is this LLM is also not having access to my personal information. Right. Personal information in the sense whatever information I have in my Gmail, or let's say if I am an enterprise organization, I am Infosys or TCS or any other company, then definitely I have some data which is very much, I mean, proprietary to my company, which is not exposed or which is not available on the public domain. So there is no way these LLMs are trained on some company's proprietary data, isn't it? So the LLM also lacks on the personal information basically. And the fourth is also the same thing, access to the company's information. Personal means your basically Gmail or your own accounts, Notions database, and company's information as I described, the data which is private to that company. Right. So any LLM which has been trained lacks basically these kind of informations. Right. So it will fail basically if you try these things. So what is the solution? Right. The solution is basically RAG, Retrieval Augmented Generation. Since that model is not having the information, what we try to do is we provide that information to the model itself. And how do we provide that information? We will provide it using some vector database. Okay, for example, there is a product, right? There is a company and it has a catalog which has maybe thousands of products which is not available in the public domain. And if you simply ask an LLM, how do I reset my device? If you give the name of your device, then it may give you some general instructions, but not very much specific to that particular device, right? But the company or the manufacturer or that device will have catalogs and, some guides or troubleshooting guides, SOPs, which can help us to get the answer. So what I will do is I will take that catalog information and I will basically put it in a specific database or a special database, which is called vector database, right? So I will take all those informations, those PDFs, those docs or PPTs, whatever information or in whatever a structured or unstructured manner I have, I will put it into one vector database. And then I will also write some prompts basically. Okay. In my application, I will write some prompts. Now, when the user asks any question, so instead of directly going to the large language model, first that question will be fired on my vector database. And since my vector database is having that information, which is not available on the public domain, I will be able to get some information out of it. And once I have that context, what I can do is along with my question and prompt and the context, now I can provide this information to the large language model. Now it should be able to answer my question. Okay. Does that make sense, everyone?
Yes, it
Yes,
makes
yes.
sense. But I have a question. Is this data previously need to be cleaned up or how it is?
Yes, I mean, there is a pipeline basically, which I'm going to show you, right? So yes, this data needs to be cleaned. The cleaner your data is, the more organized your data is, better your solution will be basically, right? So that's why this AI race is basically those companies who are having their data more in a very structured format. They are going to win this race, right? Otherwise, what will happen? Most of the companies will struggle organizing their data because AI needs some data, right? So if it's not already well organized, then it will definitely struggle. And you have to put a lot of effort in making it clean and making it available to the LLM. Okay, so I will show you the entire pipeline in just few minutes. I think your question will be answered there. Anyone else has any question?
Yeah, Shred,
Yeah.
one question. It's in using RAG, it's necessary that it's always be a vector database, or I can like make a search from some other sources like
It can
web.
be anything. It can be
It
anything.
can.
Any third party, basically, right?
Okay.
Which can basically help our LLM to get the context, right? Right now,
Okay.
LLM is having no idea what you are asking. If you ask what
Mm-hmm.
is the promotion policy for Infosys, it
Mm-hmm.
may not have any answer, right? So whatever be the way, it can be web, it can be database, it can be some external API, anything
Okay.
that is
Okay.
a part of
Okay.
the RAG. So it has two
Okay.
main things. One is the retrieval, where we basically retrieve the data. Right? It searches
Mm-hmm.
external sources like document, database, or web for relevant information. Once it has
Mm-hmm.
that information, then there is something called generation. It then uses that
Mm-hmm.
retrieved information to enhance the language model's response, grounding it in real world up to date data.
Okay.
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 So that's why
Surendra,
the name is retrieval augmented generation, means we are basically retrieving and we are
Mm-hmm.
augmenting our prompt for generation purpose. Retrieval augmented generation.
Okay.
Yeah. Please, someone is asking something.
yeah, Akash this side. So I
Hmm.
was saying this data which we are storing in vector database is interacting with the LLMs, right?
Yeah. I will show you. Yeah.
So, I mean, will there be not any security breach? I mean, this data is being sent to the LLM. So,
Mhm. But that
how?
LLM basically we will be hosting in our environment. Right now, if you see, all the enterprises are having these, I mean, platforms, right? Our company may have, data in Azure. Other company may have their data in AWS. Some other companies is using GCP, right? So what is
Okay.
happening is, since we are having our own platform, right? We have our own account. Microsoft Azure account will be created for us, right? And we will be given the database. We will be given, I mean, we can store our data in the blob storage, and we can also define the security, right? Whatever database or data files we have in our system or in our account, we will be making it secure, right? We will create the rules, which IP, which port are open, and which
Mm-hmm.
regions are allowed to enter into my network. We also create those VPCs and subnets, right? If you study
Yeah.
the cloud computation, you will see, right? Once we create our account, we create VPCs, we define the IP addresses, we do all those things. We create that firewall basically so that no one from outside can access our system. So this LLM, which we are talking about here, will be inside our account,
Yeah, yeah, got
right?
it. Got it.
If I'm building one application for, let's say, Bupa, right? So Bupa will share their Azure account, and we as a vendor, we will log in into their system. They will give us the access, and we will deploy the model in their account, and we will build the application within that platform only, right? Because the data is already there. Our application will take the data, will vectorize, will put it into the vector database, and then it will inference the model, right? But yes, if you are doing something like you are doing the web search, then definitely it has to go outside that particular account. And that's why scraping is not allowed in most of the companies. You have to take approval. I face this in my company, right? So we have to take a lot of approvals from the security team or the compliance team, and they usually don't allow you to scrape the websites, because I had one requirement where I had to enrich the data, right? So enrich the data means, let's say we have some parts data. I have a bulb or a fridge or any item, and so I had to basically put the values for its attributes. What is its voltage? What is its dimension, length, breadth? Whatever you see in the Amazon, right? If you are going to buy a product, a cell phone, it will say, right, what is its weight, what is its length, what is its color, right? So I had to basically go to the internet and pull those information. But then we were not allowed to scrape the websites. We could not go into a particular website, and then whatever data they have, we have to use some scrapers. So that's basically not allowed. So we then use there is something called SERP API, SERP API. Then we use search API, which is very much similar to the Google search, but that has limitations basically. Right. So yes, you are also right. There are some limitations. There are some security concerns. That's why these approvals are needed before we do anything. All right. So anyone else has any questions? Otherwise, I will proceed. We are good.
So,
Yeah.
yeah, so Abhay here. So in
Hmm.
ChatGPT and other Other elements are also, when we do a query, uh, there is a deeper research mode,
Deep research, correct.
uh, or thinking mode. So uh, is that RAG? Does it
Yes, 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 yes. So the chat GPT interface, if you even ask any today's event, right? And anything which is a recent event, current affairs, it will be able to answer. Because chat GPT is not a model. Chat GPT is an application which under the hood using all these things. It's using RAG, it's using agents, it's using lot of other things, right? Deep research and all those things. So there is an application which is built around that LLM, which is helping LLM to get the right information, and grounding is being done basically.
okay?
Okay, so it goes to the internet also, it scrape the data also, it does all those things. If you use, I mean, Perplexity, its main use is that it will go to the web, it will scrape the data, it will get the information, and then finally it will, synthesize the information in the form of a response. That is very good for the research. Let's say Trump has announced that, okay, there are 25% tariffs on India are imposed. So what you can do is you can go to Perplexity, and if you are having this ChatGPT Pro, or there is one more plus, then what you can do is you can basically run those deep research, and then what it will do is it will go over the internet and it will find, if you say like, tell me what are the different stocks which will get benefited, and what are the stocks which will get, a hit after these restrictions. So what it will do is it will go and see, okay, Polycab is an company who are basically importing certain things, or they're exporting it to the US, so that will get tariffs. So all those kind of things you can do by deep research basically. Okay.
Okay.
So let's talk about RAG over unstructured data. So you can build RAG over structured data as well as unstructured data. But whenever we talk about RAG, it's like 80% or 90% of the time, we are talking about unstructured data. That is the data which is lying in the Word documents, HTML files, or text files, right? And the data which is there in the database is a structured data. Already we have the tables and schemas created. And CSVs and Excel file, are termed as semi-structured data basically. Right? So RAG can be done on top of all the information, all kind of contents, but we will focus more on the unstructured data because that is the power of the LLMs. It is very good at NLP, natural language. Okay, so what we will do is the first step will be to take our unstructured data and to create embeddings out of it, and we will store it in a vector database. So step one is loading the data, unstructured data. Vector databases stores the documents as vectors that capture meaning. We will deep dive into embedding in the next slide. Vector representation allow us to measure the distance between the vectors. Okay, so let's move to the next slide for the better understanding what is an embedding. So what happens is, just like large language models are there are some special models which are called embedding models. Okay, so these embedding models are trained in such a way that if you give a certain text to it, what it will do is it will create its mathematical representation. Okay, for example, if I give it a word, then what it will do is, let's say it's a 3 dimension, right? X, Y, and Z dimension. So once you pass a piece of text, this embedding model will return me a vector. That vector will basically be the coordinates of this particular point. Okay, so since this embedding model has already been trained on some data, so if you give it a word, it will say, okay, for this word, the embedding is like, for example, -2, comma 3, comma -4. Those are basically the coordinates. Essentially, what it is doing is it is creating a vector out of it. Okay, let me draw it. For example, for this point, if I pass it to the embedding model, it will generate one vector out of it. Okay, it will decide its coordinates based on some characteristics. Okay, and the beauty of this is that once whatever content we give it to the embedding model, and once it finishes all the vector creation or convert the word into some mathematical representation, because our LLMs are basically what? They are statistical calculators only. They don't understand the words. So we need to convert the words into some mathematical format, some matrix kind of thing, some mathematical forms or vectors. Then only it will do some calculations, attention mechanism and all those things, right? So we use embeddings to create the mathematical representation of our text. And the beauty is that once you create the embeddings of the similar words or the phrases which has same meaning, they will be grouped together. Okay, for example, I have two sentences. The cat is sleeping, and I have another sentence, a cat is taking a nap. Essentially, they mean same, right? So when I create two vectors out of these two sentences, they will be lying together, right? For example, they will be like this, these two vectors. Okay. If we talk about this bunch, these are the text which means almost similar things. The more close they are to each other, the more similarity they have. So that can be found with the help of theta or cos theta, right? Mathematically, they calculate the cos theta or theta, which will tell how similar these words or these phrases are, right? Right now, I'm showing this you in 3 dimension, but these embedding models are trained in such a way that they create those mathematical numbers or vectors in 1500 dimensions or 3000 dimensions. That is basically specific to each embedding model, but this is the range basically. Okay, let me read it out. Embeddings are generated by using a machine learning model, typically a transformer based model like BERT, OpenAI's embedding. So I will show you OpenAI embedding models. There is one text small, other is embedding text large, right? We will use those embedding models. These models take a piece of text and convert it into high dimensional numerical vector. So whatever vector space we have, they will create that vector in the vector space. This model is trained such that pieces of text with similar meaning are mapped to similar regions in the vector space. So there is a huge difference between the vector databases, which will keep the vector database will hold these vectors, these embeddings. These embeddings we are going to put in vector database. Okay. And initially I said, right, these are some special databases. These are not like Oracle databases or MySQL databases. In MySQL or in conventional databases, if you are performing any search, that search is keyword basis search, right? If I say where name is equal to Rahul, then it will fetch the record where the name is exactly same as Rahul, not the meaning of the Rahul. Getting? But this vector database has a special thing that if I'm, let's say for these embeddings, if I fire a query and I say what the cat is doing, and if I convert my question also into a vector, then it will basically, and if I do a search, it will give me these two vectors as my response. What it will do is it will make similarity search, right? It will create the vector out of my question. Since it is a vector, that vector will lie somewhere here, right? So it will fetch the two closest vectors of my question and then give it in my response. So once I have these information with me, if I give it to my LLM saying that this is the question what the cat is doing, then my LLM can understand the cat is sleeping, a cat is taking a nap, and then it can generate the answer. आप सबको समझ में आया guys? Does that make sense? What is a vector database and how embeddings are created?
Yep.
So does this vector database and embedded have access to different ML models? Because from this example, like in cat example, it
Uh-huh.
shows that have vector close to each other,
Correct.
which is similar to how k nearest neighbors look
Mm-hmm.
like. So for different cases, will it have access to the different
So it will not
models?
have access to anything. Rather, that vector database functions in such a way that it uses that KNN algorithm while doing the search. Getting? it will use KNN algorithm to find out the nearest neighbors or the closest sentences.
Okay, but for some cases, some other model would be more accurate to get better
So
better.
basically that is up to that, I mean the provider of the vector database, what algorithm they have been using under the hood, right? So we as a developer are not bothered about that, right? So there can be combination of these algorithms also, right? They may be using hybrid search, sometime keyword search, plus sometime semantic search. So this kind of search is called semantic search, right? The search on the basis of similarity is called semantic search. They may do semantic search, they may do keyword search, sometime they do hybrid search, right? So that is more up to the provider of that particular vector database. Okay.
Okay. So we don't have to
Correct,
particularly
correct.
call a
Exactly.
particular algorithm and then train it. So,
Correct, correct. We simply will do, once we generate a vector database, we do something like vector database dot retriever. So it will give us a retriever, and then we will do retriever dot get, k equal to 5, then it will give 5 nearest vectors. If you give k equal to 3, then it will give 3 nearest vectors. Okay. So that's a layer of abstraction basically. Okay.
okay.
So that's on the embedding. So now if you see the end-to-end pipeline, it will give you more idea what we are talking about. Okay. So this part is called ingestion. Okay. This is my ingestion part. Next is my retrieval and generation part. Okay. So let's focus on the ingestion part, how it is ingested. So we talked about, we have some unstructured data. My first job is to use some loaders. There are some loaders because these are unstructured data are in different files. I may be having 10 Word files, I may be having 10 PDF files or 10 PPT. Then I will use some loaders basically. Those loaders are specific to the file format. For example, for PDF file, I will use PDF loader. For HTML file, I will use HTML loader. For docx, I will use docx loader. And the output of these loaders, and from where I will get these loaders, from our framework. For example, if you are using LangChain, then we will get the list of these loaders from my LangChain. Okay, there is something called Spy PDF loader, which we will use to uh, load my PDF files and to extract the text. Okay, see, after these document loaders, what we will get is we will get extracted text. Whatever text which was written in these documents, I will get my text extracted out of it. Okay. And then what my next step is to use text splitters. So there is something called text splitters. So these text can be, if my PDF was 10 page long, I will have 10 pages. Now I cannot just, I don't want to create embedding of 10 pages, right? So what I will do is I will create chunks out of it. Maybe I will use 5 or 6 lines of text as one chunk. And then once that finishes, I will make it second chunk like that. So I will chunk my data into smaller pieces. Okay. Once I do that, then I create my embedding using some embedding model. That embedding models can be from the Hugging Face. It can be from OpenAI. It depends what you want to use. So once that is being done, I will have my chunk in mathematical form. Now I have these numbers, right? This is what I was looking for. Once I have these numbers, I will put all these vectors into my vector database. For example, I can use ChromaDB. I can use Pinecone. I can use FAISS from the Facebook. So there are a lot of, vendors who provide vector databases. So I can use any one of them. Once my data is inside, once this ingestion is done, what will happen is, and let's say the user asks any question, what the cat is doing. Okay. So my first step is to convert my question also into a vector. And this time I must use the same embedding model. Otherwise, what will happen? They will not be compatible, right? So I must use the same embedding model for converting my question also into the vector. And then what will happen inside this vector database, a search will happen and it will be able to find the nearest vectors to these vectors by doing some cos theta or theta. Okay. It will compare this vector with all the available vectors and tell me the top 3 nearest vectors. Now these 3 chunks are basically talking about the cat. Okay. And then I will put these chunks inside my query, right? I may convert them back into my text, and then along with my query and these chunks, I will give it in my prompt to the LLM. Now LLM has the right context. Now it knows what the cat was doing. Earlier, it was not having any clue because it was not trained on that kind of data. Now it will give me right answer. So this is the end-to-end flow of retrieval augmented generation. ठीक है? Makes sense? This is very important, and this is basically
So
used
I
across the
have
industry. Yeah.
I have one question. So
Mhm.
this data, what we are storing in this vector database, right?
Mhm.
So is it just means a metadata kind of thing, or is it some kind of means we are not duplicating the data, right? What we have in this unstructured data, or is it using this text filter? We are just finding that uh, relevant data and then we are putting it to the embedding. Is it
Yeah.
what we are doing?
Yes. So I mean, we are extracting the text. I will show you in the code, right? And you are correct. While creating these chunks, we can also associate some metadata with them. Okay. Every chunk will have its metadata. So what we will put in the metadata, we will put from where it is coming, right? So once I get the final answer, how the user will be assured that the answer is actually coming from the content and LLM is not giving it from its own knowledge. The
Mm-hmm.
best, to assure this, the best thing is to use its metadata, which will basically tell once you get the response, it will say this is coming from this document. It will give the name of that PDF from where this chunk is coming. It can also tell the page number. So it can give you some references, right? So that you are assured, okay, this is coming from some genuine document only. It's not hallucinating. That is called citation.
But are we storing everything what we find out in the unstructured data? Unstructured data.
Yes, yes. I mean, whatever text we have, we are storing it, right? We are chunking and storing it. Are you talking about the images or other things?
Means yeah
Tables?
means
Uh,
means is it not duplicating the means suppose we already have data somewhere, right?
Hmm.
Now in the vector database we are though we are storing it in an embedding format,
Yes, we
but
have to do it. I mean, I got your question. So if you are having some S3 bucket or maybe some blob storage, then you are saying we
mm,
are pulling data from that, all these files we are pulling and then we are vectorizing it. But we have to do it. There is no other option
okay,
because we want to do semantic search,
okay.
right?
So
We have
it
to.
means that anytime
Hmm.
whenever we have change on that blob storage, uh, we
Correct,
have to
correct.
again
We
train that
have
data.
to
We have to again update
incrementally
that.
we have to
Okay.
incrementally add those vectors, right?
Okay. Got it.
Okay. So with that, let's jump on the code. Okay. This is what we were doing in the last class. Streamlit. Let's use the same workspace. Let me activate my environment, V and V1 activate. And I have this code. So what I'm doing is I'm installing LangChain community, LangChain Chroma, LangChain Grok, all these libraries which we're already familiar with. These are my keys. So by the time it installs, let me go and grok keys. Then I have got all my keys. So if you want to directly run on the Google Colab, I think I could have done that also. But somehow I opened the VS Code, so I'm just converting all these things. Otherwise, this is compatible with the Google Colab. I think my keys are also set there. Done. This is done. I don't know why it's stuck. So we are installing PyPDF loader. So I was telling you, if you go to LangChain, if you go to documentation, if you go to integrations, if you see loaders, do we have the loaders here? Chat loaders. PyPDF loader. Document loaders component. Document loader. So there is a long list, right? You can use any of these. If your input document is PDF, you can use PyPDF, unstructured, Amazon Tesseract, any of these library, right? If you are on the cloud, if your documents are on the cloud, you can direct create integration, AWS S3 directory or AWS S3 file. So LangChain comes with almost document loader for almost all the sources, right? Wherever your data is, even if it's on the web also, there is something called as the web loader. And you can simply give the link URL of the web. It will take the document from there. Okay, so that was one thing. So what we are using, number one, or maybe I will remove this. Document loaders, we are using LangChain. For example, for our case, PyPDF. And if we talk about vector database, we can use Chroma or FAISS. And for embedding models, we can use basically either Hugging Face or we can use OpenAI's embedding model. And what else we need? Yeah, for LLM, we can use either Grok. Within the Grok, basically, we can use Llama 3.1, 70 billion parameters, or we can use OpenAI GPT 4o mini. Okay, so this we can use. Let me show you all these things. So if you go to the chat models, let's say you know how to write code for any of these chat models. If you are using Google Gemini, you can just copy paste the code from here, right? You need to install this library and this piece of code. This is using Gemini 2.5 Flash. And if you want to use Anthropic, this is so the code snippet is always there, right? And if you talk about the document loaders, we have already seen vector stores. If you want to use OpenAI models, then you can use this piece of code. So this is the name of the OpenAI model. So there are two models. One is large, other is small. The small is having 1500 dimensions and this large is having 3000 dimensions. So what does that dimension means? Basically, if you have a piece of text, then it will have 3000 coordinates. Just like we just had the three coordinates, right? X, Y, and Z. But that embedding this vector space is having 1500 or 3000 dimensions. Those many numbers will be generated, right? And these are basically correct. These are the basically different characteristics on the basis of which its coordinates are decided. Okay, so we can use these one. If you are using Hugging Face, then we can use sentence transformers, right? So the code is available for each and everything. Embedding models we have seen. What else, right? So this is what we need. Let's go back to our collab file. So my PyPDF loader is installed. This is my user data. Whatever keys I need, it's already there in my Google Colab. So it will pick from there. No need to change any piece of code. And these are the libraries. You can see PyPDF loader, Chroma database, OpenAI embeddings. Text splitter I'm using is recursive character text splitter. So there are different type of splitters, right? We can, maybe we can say one page should be one chunk, next page should be second chunk, or maybe I can say if there is a document and there is some kind of titles are there, then the heading number one, whatever we have beneath heading number one, that should come in the one chunk. Heading number two, afterwards it should be second chunk. So like that, we can decide our strategies, how we want to split our document, how we want to chunk our document. So right now we are using recursive characters text splitter. So there is a very nice this tutorial on deeplearning.ai. Deeplearning.ai, who is founder of this particular company, guys? This gentleman, right? Andrew. His name is Andrew Neg. He has a lot of contribution in, in spreading awareness, and he has this website, and he's also founder of, I think, co-founder of Coursera, right? So he has done a lot of good things in the area of AI, especially he's a good teacher also. Okay, so this deeplearning.ai is also his initiative. So if you click on explore courses, you can see the short courses. So whatever latest or whatever companies who are basically working, so what he does is in collaboration with them, for example, in collaboration with the Databricks, he has created this course. Astronomer, right? You guys have heard about the Astronomer company? It was famous for some other reasons recently.
Yeah, Coldplay.
Exactly. So that guy was CEO of this Astronomer, right? And then Anthropic. So you can browse, right? There are some good content as well. So if you browse, so there was one course on this. mm, what is that? How to build applications using LangChain, right? So within that course, he has talked about the different chunking strategies. Building system with the ChatGPT API, ChatGPT prompt diffusion model, LangChain. So this is what I'm saying. So he is the founder of LangChain basically. Okay. And if you go in this course, he basically talks about that memory chain, question answers evaluation. I think there is another course. Chat with your data. Let me see this one. So here he talks about how to split the documents. Okay. He is talking about the different splitting techniques. So you can also go through these courses as well. They are also very helpful. They are very specific to the LangChain. Okay, so what we are going to use is our recursive text splitter, and then we are using string output parser, runnable parser, you already know. And I need to put my PDF. I need to put my PDF here in Google Colab. Okay. So now my first step is, if you let me run the imports. So if you do ls, right, because this is a shared drive on the Google environment, Google server, if you do ls, it's like sample data slash, this is available right here. Okay, so I can simply, without giving path, I can do PyPDF loader and the name of the file. This is a loader. When I do loader.load, it will basically create bunch of documents. If I see the length, it's exactly same as my source document. Let me open my PDF. So it has how many pages? It has 4 pages. Okay. So this talks about a company, Saran AI Labs, about Saran AI Labs, and then what is vision, mission, employee benefits, right? onboarding company, what are the company policies, the working hours, and all those things. Right. So just think that these are the internal policies which are specific to a particular company, and the internet is not having access to this kind of private data. So we will take this PDF and we will chunk it and we will load it in our vector database. So the number of pages are 4. That's I was trying to show you. These are 4 pages. Okay. So it has created one doc per page. Now, if I want to see what is there on the last page, right? So I can see all those pages, right? If I want to see the first one, it's basically welcome to the AI labs. If I go, this is the text. What it has done, it has extracted this text, welcome to the AI labs, page 1, and this content. Cool. So now I have extracted the text. My next step is to use this splitter. If you go back to my diagram, after loading, after extracting text, I need to create the chunks. I need text splitter basically. So I will use this text splitter, which is again coming from LangChain. This is my chunk size. I'm saying my chunk size should be 500 characters and there should be an overlap of 100 characters, right? For example, if this is my text and this is 500 characters, then my second chunk should start from here, right? There should be 100 characters, which should be common in 1 and second. This is to basically retain the context. If I, let's say my 500 characters completes here, then my next will have these many characters. So there is a loss of connect basically, right? The context is lost. So in order to retain the context, what is the talking point in my previous chunk, we usually have the overlap of 100 characters or so, right? And again, this is not something a very hard limit. It depends on the type of documents or sometime hit and trial, right? So once I have my text splitter, I will split the documents. This is my 4 documents were there. I will put it in the source in the input and these many splits are generated. So if I check the length, there are now 12. If I go to my first one, it will have just this much amount of data, right? Earlier, my page was having this much amount of data. It has created 3 chunks out of my first page probably based on my parameters. Okay, now I am dealing with 12 different chunks. Now I am dealing with 12 different chunks. Okay, my next step is to create embeddings. So I will create Chroma from database, will give all the splits and my embedding model, where I instantiated my embedding model. I don't know. Will it work? Let's see. It's working. Okay, so this is directly, I mean, we already set this key, right? OpenAI key, where right here. So it has the OpenAI key and it has taken this, instantiated this object with the help of this key. And if you want to mention the name by default, it I think takes the large model. If you want to specify the model in the parameters, you can specify which model you want to use. Okay, I have the embedding model, I have my splits, right? And this is my vector database. So what it will do, it will take these splits, use this model and vectorize my content and put it into Chroma vector store. This is done. Now what I need to do, I need to create a retriever basically. Now I have the retriever. On top of this retriever, now I can fire my question, right? So right now where am I? I am right here. Okay. Now, if I have this vector database and its retriever, I can directly ask some question. It will give me some relevant chunks. Okay. So right now this user is not asking any question, just in order to test whether my vector database is right or wrong. I can simply take the retriever and ask any question and see whether it's returning me some right answers or not. Okay, so if I run that retriever dot invoke, retriever is what kind of object? It's again a runnable object, and we have learned in the past all runnable objects expose same methods like invoke. So I can use this invoke method, and my question is, what is run AI? If I run that, this query will be run. This query will first convert into vector embedding, and this retriever will basically do a search in the vector store, and it will give me some response. Let's see the response. So this is the response. This is basically the chunk. This is not the response. This is just the chunk. Are you getting, guys? So far, I have not provided this chunk to the LLM. I am just trying here by directly hitting my vector database whether it's giving me relevant chunk or not. So if you see, my question is, what is Saran AI? So it has picked the chunk as the one chunk which is talking about Saran AI Labs. Yes. Welcome to Saran AI Labs, page 1 about Saran AI Labs. Saran AI Lab is a pioneer, blah, blah, blah. Okay. And is there any other chunk? Yes, the second chunk is also there, which is also talking about Saran AI. So we'll see Saran AI somewhere in the content. Employee benefits at Saran AI. So this is also talking about the Saran AI. So it has done the similarity search and it has pulled these chunks, the most similar chunks. This also must be having something, saranailabs.com. Okay. So we just try to test it. Now get back to our main flow. After doing this, we have to build our chain. We know what is the chat prompt template. From the core we have imported. This is our prompt. You are an onboarding assistant for Saran AI Labs that answers questions based on the context provided. This is my context. From where this context will come? This context is going to come from my vector database, isn't it? And this is my question. And I will build this prompt, chat prompt template, from template, and this is my template basically. Okay. So how many variables are there in my prompt template? Just two, context and question. सबको समझ में आ रहा है? Is it making sense, everybody?
Yeah.
Chalo, I also have this helper function, which is nothing but basically this is joining, right? This is just the formatting of the retrieved documents. And now I'm importing chat grok. This is my model name. And this we know how to build the chains. This is my dictionary. This is my first key. I have the retriever. Whatever question I will ask, first it will go to my retriever. And retriever is very intelligent. When we ask a question to a retriever, it gives me some response. That response will come. That response I will pass to my format document method, my custom method, which will do some formatting, and whatever the output is, it will be set to my context key. This is key and this is value. Also, I want my question to be passed as is without doing any manipulation. That's why I'm using runnable pass through. This we have talked in very much detail. So this question will again be set as is to my question key. Okay. End of this step, I have a dictionary with two keys and their value. My context is set because I have retrieved semantic similar information from my vector database, and my question is there. I will pass it to my prompt. Prompt will fill the context. It will go to the LLM, and my final answer will be synthesized. So if I run my final step, tell me about Saran AI Labs. It has retrieved the chunks and all those, and it has provided to the LLM. LLM will prepare the final answer. Okay, with those chunks. Now it says, welcome to the Saran AIs. I'm excited to share that with you, the details about our company, right? We focus on three main areas. This is our mission at Saran AI. We are blah, blah, blah. Okay, so you can see this answer is having some content from my third chunk, some content from the second chunk, and from the first chunk. But those chunks were very abrupt, right? So LLM basically prepared the final answer. Okay, this is all. Was it exciting? No? Boring? Everyone?
So here in this code on which part it will show that that those text would be text are converted into numbers, and then
So that is being taken care by LangChain.
okay.
Okay, that's why we are using LangChain, because we don't want to go into that details. Right? There are a couple of parameters if you want to control how many chunks should be retrieved. Is it top 3 or top 5? Those can be done into these methods, right? Wherever we are defining retriever and we are doing the search, we can mention all those things. Otherwise, all that complexity is being handled by our these libraries. That's why we are using this LangChain.
So Surendra, like it will not manipulate the data. Like whatever we feed, like it will give only that information, right? It will not like change the font. I mean, it will not change any of the reformatting the sentences or something like that, right?
Yeah, I mean, basically, whatever chunk we have provided, it will understand. My LLM has power to understand the language, right? So it will understand those chunks and it will definitely understand our question. So based on those chunks, it will prepare my question, my response.
Okay, and then
Okay.
like whatever I see there, like building AI-driven applications,
Mm-hmm.
and like the same context is being given, right? Like whatever we have it in the PDF, it will not reformat the sentences or something like that, right?
No, I didn't get.
I mean, did it?
If the question is same, the same type of chunks will be retrieved and the same thing will be responded. If the question is different, different chunks will be retrieved and then the final answer will also change, right?
Yeah.
Hmm. So, but when we develop a full-fledged application, we basically design it in a proper way. We tell in the system prompt, right, how it has to behave, that whatever chunks are provided, it should answer only on behalf of that. If there can be a possibility, right, I am asking a question which is not there in my vector database, isn't it? So I will be telling my LLM that if you are not able to get proper context, then don't try to answer yourself. That will help me to reduce hallucination. Otherwise, what will happen? LLM may try to answer of its own from whatever knowledge it has. Correct? So those kind of things we have to do in our system prompt. That's what we will do next. This is, we have this as your assignment, or if you want, we can do it right away. This is an onboarding assistant. Let me see. Okay, so you want to try yourself or I should go ahead? So what you have to do in this one, that the same document you have to use, and whatever knowledge we have so far, we also know how to build chains. We know with this code, you actually now know how to create the vector database, how to deal with the retriever and things like that. Now, this by using this code, you have to put one user interface using Streamlit that will basically expose uh, the chatbot, right? The chat interface where the user will ask question. Right now, we are asking the question in the code. There, basically, the user will ask the question in the chat window, and that question will be passed to my chain, and then it will get the response. And I have to maintain the history of my conversation in the session states, right? So those all things you need to do and build one application which will be acting as a onboarding assistant. So if any person who is joining a company, what we are doing is we don't want him to, run here and there, ask his questions to the finance team. Sometimes he's raising a question, some concern to the HR team, or going to the systems IT team, saying that where is my laptop? What we can do is we can take all the policies, we can create a knowledge base, and on top of it, we can vectorize that data, and we can build one application where all his questions can be answered. Right? As a new joiner, I may be curious how many leaves I will get in my first month. So I can ask that question as per the policy, how many days of leave I can avail in my first month. Then my chatbot will look into the policies, it will get the uh, right answer, and then it will tell you, okay, since you have joined, you are on the probation, you are just allowed to take 2 days of leave or something like that. Right. So these kind of chatbots are very much, there in all these companies these days. Right. So we have to build that kind of application. Okay. Can you build yourself? I will share this content. So what it will do, there will be two inputs to the interface. First input will be the employee profile. So what we will do is we will use some Python code to generate a fake profile. So once the user says hi, it will it will generate one profile. Okay, this is Mr. XYZ. He is working in this department, finance department. His grade is this, and his designation is that. His role is this, right? So I will generate one fake profile, and then that profile along with my question will be sent to the vector database. My profile will not be sent, but my question will be sent to the vector database. It will pull the relevant information, and then it will show it on the user interface. Okay, if you want, I can show you the code right away. If you want to try yourself, you can do that as well. Let me see if I can run it since we have the time. This is our session. Okay. So what I will do is in this requirement.txt file, I have all the libraries which are required. Right. So this is the best practice. So I have listed all the libraries along with their version. All I need to do is I need to create one virtual environment like Python minus m venv1. Is it already created? No. I will create this environment. Permission denied. venv1 is there, right? Yeah, it's already there. Let me use that. This is activated. Let me see if it has all the libraries already installed. Looks like. Okay, let me give it a try. To run this one, Streamlit, run what is my app.py. So right now what it is doing is, since we are running it for the first time, it's basically taking this input document, creating vectors, embeddings, and putting it into a vector store. This is good. Okay, so this is my application. You can see this, we have created this, what we call it, sidebar. No, not sidebar. We have created this thing, what this is called.